Hello friends, welcome to Suresh Aggarwal's Mathematics Shortcuts. Your one stop for learning so many mathematics short tricks and smart methods through which you will be able to calculate 10 times faster and crack all those quantitative aptitude exams, whether at school level in different Olympiads or at college level. If you want to get into a better university, you have to appear in the entrances, right? And then at professional level, SSC, UPSC, railways, banking, CAT, so many exams in which you find the application of smart tricks to crack the quantitative aptitude, because you have around 200 questions to be solved in 2 hours. So it requires smart tricks, and if you know the traditional methods, it doesn't mean that you will be able to crack the questions in minimum amount of time. So that is the intention of Suresh Aggarwal's Mathematics Shortcuts, creating a space for you where you can learn these skills and upskill yourself to crack those exams. So what do we have in this video? We have posted so many videos of cubing, and once you start finding the cubes, finding the cube root also becomes easy, because if you know cubes up to 10, it helps you calculate the cube root also, and that you have seen in the previous video in which I told you the beauty of the observation method of finding the cube roots. So this video is an extension of that method, which is the cube root of perfect cube decimal numbers. So when we talk about decimal numbers, obviously students get scared, decimal numbers, and suddenly you realize, oh, it's not all that scary if you know the basics. So this particular topic is a part of our chapter 4 of the ebook of short tricks, and if you want this ebook of short tricks, a compilation of 350 such short tricks to make maths easy for you and calculate 10 times faster, then you need to send me a message on WhatsApp. This is the WhatsApp number 9896369963, and all these details which I have written here, they are in the description of this video as well. So friends, let's understand the concept of the trick so that we can apply it to solve 5 or 6 questions, and then I'll leave it to you. You will practice and let me know in the comments, okay, whether the trick is really working for you or not. So the concept used in the trick. What are the various things you should know? The first thing is the cubes up to 10. So 1 cube 1, 2 cube 8, 3 cube 27, 4 cube 64, 5 cube 125, 6 cube 216, then 7 cube 343, then 8 cube 512, and 9 cube 729. 10 cube, it doesn't matter, like this is the easiest one, 1000. So this is the first concept you should know. The second concept, the unit digit of a perfect cube number. See, all these cubes, they are ending with a unique digit. See, this ends in 0, this ends in 1, this ends in 2, here we have 3, 4, 5, 6, 7, 8, 9. See, no digit repeats itself. So when you cube a single digit number, the unit digit number of that cube is unique. Okay, so if I ask you that there is a cube root of some number, a big number that ends in 2, so you should know that your answer for this question is going to end in 8. Why so? Because 8 cube is 512, which ends in 2. So this is one of the very important competencies. And the third is the most important part. Like suppose I am finding the cube of 2.1. So if I find the cube of 2.1, since we have only one decimal place in the base here, so when I find the cube after decimal, you will have 3 digits and it forms a triplet after decimal. So 3 digits after decimal means 1 digit after decimal in the cube root of this number, right? Triplets. That is one more important thing you should know. All triples, they constitute a single digit in the cube root, right? So if you know these things, we can now apply it to solve some questions. Let's have this question 1.331. See, 1.331. After decimal we have 3 digits, so your answer will have 1 digit before and 1 digit after decimal, like this. Now this triplet is ending in 1 and there is only one single digit which whose cube ends in 1, which is 1 itself, and so this is going to be 1. And for the part before decimal you have this 1, and 1 is greater than or equal to 1 cube only, and therefore this 1 forms the remaining part of your answer, giving cube root of 1.331 as 1.1. Now similarly here you can see 3.375. Now the things are starting to get complex, but not that complex which will make you feel troubled. So 375 is a triplet. So if I have to find the cube root, my answer will be decimal 5. Why? Because it ends in 5. And there is only one cube which ends in 5, which is 5 cube itself. 5 cube is 125 ending in 5. Right? So ends in 5 means decimal 5. And before decimal we have 3. And 3 is greater than which cube? It is 1 cube. 1 cube is 1. 2 cube will be 8, which is greater than 3. I don't want to go beyond 3. Okay? Either equal to 3 or less than 3. So 1 cube is the number, and that 1 forms the remaining part, giving me the answer for cube root of 3.375 as 1.5. And you can check using the calculator, the answer is going to be very, very accurate. Likewise, if you have numbers like 8, 32 and 5, 832 ends in 2. So which cube ends in 2? You should know that it is 8. And therefore this is going to end in 0.8. And remaining part is 5. 5 is greater than 1 cube only, and it is less than 2 cube obviously. So the 1 forms the remaining part and you have the answer as 1.8. So 5.832, the cube root is 1.8. Things are getting easier now, right? Let's see this. 261 and 9. So 261, it ends in 1. Only 1 cube ends in 1, right? Because it is 1 itself. And so your answer is 0.1. And what about the remaining part? It is 9. And 9 is greater than 2 cube, which is 8. So the part 2 is the number before the decimal, and your answer for the question is 2.1. So if you do 2.1 times 2.1 times 2.1, you will get 9.261 as the answer, or cube root of this number is 2.1. Easy, right? Let's have some big numbers. Here we have 5, 7, 6 and 17. So 5, 7, 6 ends in 6, and there is only 6 cube whose cube ends in 6. See? And so your answer is going to end with 0.6. Likewise 17. 17 is greater than which cube? 2 cube only. Why? Because 3 cube is 27, greater than 17. So 2 is the remaining part. Your answer is 2.6. And final question here, 937. The last number is 7. And which cube ends in 7? It is 2 cube. It is 3 cube, right? Not 2, 3 cube. So 3 forms the remaining part. Let's rectify this. This is 3 cube. And 3 forms the answer after decimal part, right? 0.3. And now the first part, 35. 35 is greater than, now the number changes. 2 cube is 8, 3 cube is 27. 4 cube is going to get over 35, right? I don't want to cross 35. So 3 forms the remaining part and 3.3 is the answer. So if you do 3.3 times 3.3 times 3.3, you are going to get 35.937 as the answer, or the cube root of this number is 3.3. Isn't that amazing? Just little bit of presence of mind, little bit of smartness, and you can crack the cube root of perfect cube decimal numbers just by watching the number. So friends, if you are liking all these videos, do click the like button, and then after liking the video, you will get an option of hyping the video. If you hype the video, give it some points, 80 points, then it has more chances of reaching to the different parts of the world. So friends, do subscribe our channel Suresh Aggarwal's Mathematics Shortcuts, and along with the subscribe button you have this bell shaped icon. Hit this icon for getting all the notifications of future uploads on your mobile itself. Practice at least 30 questions of this nature and let me know in the comment box below, is it working for you? All the best.